In this chapter, we are going to explore distribution strategies. We are interested in the idea as to what is the best way to distribute products to retailers. Sometimes we do direct distribution. In some cases, we may consider establishing a system of warehouses, and you could distribute directly from decentralized warehouses to retailers, or we could consider centralized warehouse where we distribute out of that centralized warehouse to the retailers. Another option is also to consider what we call cross-docking, where items are brought into a facility by the suppliers and then they're repackaged and shipped out to the retailers on a different set of trucks. So at that facility, little inventory is actually left. So the focus is on ensuring that we optimize the supply chain by selecting the right kind of distribution strategy. There are many different types of strategies, as I've already mentioned, and the opportunities and challenges will depend on several factors, such as the desired service level, demand distribution, how customers behave when the inventory is not available at one retailer, whether or not they will consider searching other retailers and so forth. So there are a number of factors that kind of drive that. We have two fundamental distribution strategies, where items could actually be shipped from the supplier directly to the retailer, or you have a sort of intermediate inventory storage, and that's where you get into either centralized or decentralized distribution points. When we're considering optimizing warehouse configurations, not so much in terms of internally, but the structure of the network, then we have to consider a number of things. What is the manufacturer's strategy? Is this a manufacturer that makes to stock or makes to order? How many warehouses do you have? If you have many warehouses, few warehouses, or a centralized warehouse? What is the inventory policy in terms of periodic inventory review versus continuous inventory review? What kind of inventory turnover rate that you're looking for? How fast? What kind of velocity of the items we're interested in? Whether or not the warehouses are owned by the retailer or they're owned independently by some outside distributor, and then whether or not it's owned by a single firm or a variety of firms. So these are all factors that we would consider in the optimizing the distribution strategy. Okay, so let's look at direct shipment. Direct shipment has some advantages and some disadvantages. In the case of direct shipment, well, you don't need these intermediate storage points, and so you will tend to have less sort of capital costs associated with running distribution centers. Your lead times tend to be reduced because you're shipping directly to the retailers. So as soon as you receive a demand, you're going to ship directly to them, and there's a pretty good chance. So you don't have those intermediate stages that may actually lend for the lead time. However, because you're shipping directly, you do not take advantage of risk pooling, and so the manufacturer, as a result, may have to keep larger levels of safety stock, and the distribution costs can be quite high because depending on where the manufacturer is located, you have to ship out from the manufacturer to all its retailers. Commonly used scenarios where we do direct shipment, where the retail stores require fully loaded trucks, often mandated by powerful retailers. The lead time is critical. Manufacturer may be reluctant but have no choice, and that's prevalent in the grocery industry, where the suppliers distribute directly to the retailers. So you could see a farmer's truck pulling up to Sobeys because the Sobeys is large enough to say, no, we want you to ship directly to our stores. If we have intermediate inventory storage points, and then we are considering either centralized warehouses or decentralized warehouses, We have a variety of characteristics that distinguish between the strategies. One is the length of the inventory stored at the warehouse. So in some cases, you're stocking goods, and the inventory could last a while, in which case the retailers draw down from that inventory at a distribution center. That's pretty much your traditional warehousing strategy. So distribution centers and warehouses, they will hold the stock and provide the downstream customers with inventory as needed. So in a case like that, you got to think about, yes, what are your safety stock levels and so forth. In cross-docking, however, there's no real inventory that actually remains there. The warehouses and distribution centers serve as a transfer point. You don't really keep items there, so no inventory is held at these transfer points. Centralized pooling and transshipment strategies, in a case like this, where centralized pooling actually allows you to lower your inventory levels because of inventory risk pooling, then you need lower levels of safety stock. Transshipment, which basically allows two retailers or two distribution centers to move product from one to the next, sort of creates a virtual centralized system. And so you could get some benefits from transshipment strategies if they in fact exist, right? So we're going to look at a couple of these strategies in a little more detail here. With your traditional warehousing, since as we've already mentioned, you have the warehouses simply stocking items and is distributed to the retailers on an as-need basis. So you would have to decide, even in the case of traditional warehousing, do you want a centralized distribution facility or do you want decentralized management of that system? And they have the advantages and disadvantages. So in a decentralized system, of course, each facility will actually need to manage its inventory levels. So it will identify the most effective strategy depending on the service levels, the demand patterns, and the cost-related factors. It tends to lead to local optimization because the distribution center is really trying to optimize its own profits. It really doesn't care about what else is going on in the rest of the supply chain. In the centralized system, however, because you have a chance to look at the entire chain, the objective becomes minimizing costs for the overall chain, and you tend to get better performance in that case. So we get more what we call global optimization. So, excuse me, or at least you get the performance of a decentralized system. It allows the use of coordinated strategies because everything is centralized, so you get greater coordination. If it cannot be centralized, however, if the partners can work together, if you have a decentralized system owned by different people, if the owners could actually form partnerships and sort of create a virtual centralized system, then you can get the benefits of centralization. All right? Central versus local facilities. In centralized systems, of course, you have fewer facilities, so you could reduce your capital costs associated with that. All the overhead costs, etc., would be reduced. However, one needs to always consider several factors in making the decision. The safety stock level tends to be lower with centralized systems, so that is a plus. Overhead, because you only manage a single facility, so you could actually lower your total overhead costs. You get economies of scale because you have larger volumes being stored at that facility. The lead time to market, however, tends to be better if you have a decentralized system because you could position the distribution centers closer to the retailers. Service, because you have risk pooling that is possible in a centralized system, you could actually meet the same service level with fewer inventory. But if you kept the same level of inventories, we've already discussed that earlier, that you can end up increasing your service level for the same level of inventories if you store it in a centralized system. All right. Transportation costs is, generally speaking, if you have a decentralized system, then you might be able to, it looks that because your distribution facilities are closer to the retailers, you might actually be able to do some reduction in transportation costs. But then there comes a point where if you just have too many distribution centers, that your cost could actually increase. So it's kind of difficult to figure out, because what happens is you need a number of shipments that go from the manufacturer to the distribution centers, and then the distribution centers to the retailers. So while they might be reducing the cost associated with the transportation between the distribution center and the retailers, you may very well be increasing the cost between the manufacturer and the distribution centers. And the total of those two costs, you would have to ensure that it's actually cheaper than having a decentralized system. All right. It is possible to actually develop a hybrid model where you centralize some of the items and you decentralize others. Okay, so you could actually have both of them, and the amount of centralization versus decentralization will depend on the profile of the products that you have, also the sort of lead times that are required, the service levels that are required. So typically high velocity items that are quite risky, perhaps you might tend to put more sort of commodity items in a centralized facility, more high velocity items, higher margin items closer to the retailers. In cross-docking, Walmart popularized that, and Sobeys also used cross-docking. The warehouses pretty much are just transfer points. And so you have goods arriving at warehouses from the manufacturer, and then they sort of unloaded, repackaged based on the requirements of the retailers, and placed on trucks that actually will supply the retailers. It's quite an interesting operation. But it requires that you have a really sophisticated information system, that you are able to plan and coordinate supply in such a way that all these supplies arrive, allow you to repackage them, and still send out full truckloads to the suppliers when you go across the dock from the supply side. From the receiving to the reshipment end of the warehouse. So in other words, what I'm saying here is that if you're going to use cross-docking, you have to have significant volumes, so that when you do a break bulk and you repackage, you still are sending out the trucks that are going to take the goods to the retailers should still be able to have pretty much full truckloads. If they don't, excuse me, you're not going to get the benefit. So what are some issues with cross-docking? Well, as I've already mentioned, you have to have a fairly good information system. The partners in the supply chain must be linked through a very advanced coordination system. A hybrid model can be used where you actually have part of the goods centralized and a part of the goods actually decentralized. And that depends on several factors, such as the service levels required for some of the stocks, some of the demand patterns where we look at the variability in demand, and the sort of price of the items. So cheap items or commodities tend to generally be centralized. Items that have higher velocities, higher value, which require high service levels, you tend to move closer towards the retailers. Cross-docking is an effective distribution strategy popularized by Walmart, where essentially the distribution warehouse or facility is really a transfer point. You have goods arriving from your manufacturers or your suppliers on one side, and in sufficient volume that they could be repackaged, and you have trucks that will actually take the repackaged goods and bring them to the retailers. And you want to make sure that the volumes of the repackaged goods can still lead to full truckloads. Otherwise, you may not be getting the benefit, from cross-docking operations. there are some issues with cross-docking. Of course, it requires significant investment in information technology. It requires coordination between the partners in the supply chain. It has to be a fast, responsive transportation system. The forecasts are critical because of the fact that you need to know what your various retailers require, aggregate that information, get the suppliers to ship in a very timely fashion to the cross dock, and then be able to do whatever transactions are necessary to move the product to the retailers. All right. So we will talk a little bit about whether or not centralized pool systems tend to work better than decentralized systems. Let's see what happens. In some cases, if you think of auto dealers sometimes will actually all source from the same centralized warehouse, as opposed to each of them having their own distribution center. And you can see why the cost of the inventory is so high that you wouldn't want to have each single dealer having their own sort of distribution center supplying them. So therefore, there would tend to be a sort of a centralized distribution system for a group of retailers. So in the in the context of a centralized system, for the same inventory level, a centralized system tend to provide higher service levels. We talked about it because of inventory pooling or risk pooling, and you tend to get higher sales. There is a push-pull concept, which basically means that is the demand pulling or the demand push. Well, push in this case would be sort of a make-to-stock kind of strategy, where pull is a make-to-order. So if you have a centralized facility, in demand items are pulled from that warehouse, and so that would be a pull system, right? So you have a tendency to want to move from a push supply chain to a pull supply chain, and centralized systems actually enable that. So what will happen is that in a case where you have centralized pool systems, end customers will actually benefit from it. Why? Because you tend to have, for the same service level, for the same inventory level, you tend to get better service because you have done some risk hedging by aggregating or pooling the demands from many dealers or retailers into that centralized system. More cars are available to them as a result. So how you configure that system will have implications for what the manufacturer can sell. And so there's always this issue of the manufacturer versus the retailer. Sometimes the manufacturer attempts to influence the order quantities from the retailer so they could sell more cars. But there's always the risk that the retailer could end up with an inventory risk, having too much inventory. So the text examines this issue of the difference between the performance of the manufacturer and the retailers under different conditions. So here, will GM sell more cars to dealers? And in a case like that, we want to examine, the effects of things like search, or the effect of things like one dealer monitoring what the other dealer's competitive strategy is and reacting and responding to that, right? So in the centralized system, what tends to happen is the total number of cars ordered by the dealers will not necessarily be greater, even though the customer service actually improves. However, in the case of the dealers have access to more inventory because of the centralized system, and they could potentially sell more cars. It levels out the playing field between the dealers because essentially the supply side of things are equalized or neutralized. And so certainly one dealer doesn't have an advantage over the other in terms of the supply because they have access to the same inventory. So it all depends on what their competitive strategy is that would influence their performance, right? Let's look at an example of inventory pooling. You have a case where two retailers face random demand for a single product. So there are no differences between the retailers. And we want to look at the difference between the two systems, centralized versus decentralized. And we already understand what decentralized system is, which is each retailer would have their own, each retailer would have a corresponding distribution center, whereas with the centralized system, you have one warehouse supplying the two retailers. And so it looks something like this. If you notice, we are using the same data that we used back then in Chapter 2 or even in the supply contracts. And so here's the manufacturer, centralized distribution to the retailers, and here is where you have decentralized distribution right here, okay? The data kind of looks similar to data that we've used before, $125 per unit, $80 wholesale price from the manufacturer, salvage value of $20, production cost of $35. And so you have data to look at what the manufacturer's ideal is, but also what the retailer's ideal is. So in the decentralized system, you will have matching strategies between the dealers. And when we do the marginal analysis, it turns out that each dealer will order 12,000 units, and the expected dealer profit is $470,000, with a total of $940,000 in terms of total profit, basically doubling this. The expected sales is 11,340, and then that is done by taking the weighted average of the demands. So if you double that for the two, you get 22,600. However, in the centralized system, it turns out, excuse me, that when you do the marginal analysis, you would order a quantity of 2,600. So we have to sort of, for the centralized system, we would have to look at the demand on the central warehouse, and so we would have to take the demand distribution and double the quantities. It turns out that it will order 26,000 units. So if you look at this, under the decentralized system, you order 22,000, 26,000 under the centralized system. So the manufacturer is going to prefer centralization, right? And not only that, if you look, it would appear that the manufacturer's profit also increases as a result of that. So the total expected profit for the dealers also look good too. Yeah, that's correct. So instead of 940,000, we're looking at $1,009,000, 392. So $1,009,392. So the centralized system certainly seems to offer some advantages. But what happens is that it assumes that if a customer comes, particularly when you're looking at the decentralized system, if a customer comes to a retailer and they don't have the product, the customer goes away. But in real life, that doesn't really happen. So what happens, the customer, if there's some loyalty, if you're looking for a Toyota Corolla and you went to one dealer and that product was not available, you'll find another dealer to see if they have the same Toyota Corolla, because you're loyal to the product. So that is what we call search. And a certain percentage of customers will actually switch to another dealer to find the product, and while the rest of them might say, well, you have no Corollas, I'm going to look at something else, right? So which system is better under search? If you have centralization, well, there's really no issue, because you have you cannot search another distribution center, because all the dealers are actually accessing the same distribution facility. However, when you have decentralized systems, that's when you have risk associated with that. So if a dealer knows that his competitors do not keep enough inventory, one dealer is looking at the strategy of another, then it might actually increase its inventory level because it expects customers to conduct a search for that product, and vice versa. So if they know if the dealer then knows, one dealer knows that the other company stocks a lot of inventory, then in a case like that, that dealer would want to actually stock less inventory. It doesn't make sense both of them actually stocking high levels of inventory. There will be a risk of sort of being overstocked in both cases. All right. So the dealer strategy depends on what its competitors are actually doing. And the question is, do they actually know what they're doing? Sometimes not always clear. So how does one decide on the inventory level? There is an equilibrium called a Nash equilibrium, which allows, if you could map it, it basically says that if two companies are making decisions, they have reached Nash equilibrium if they both have made a decision and on how much to order, but neither of them can actually improve the expected profit by changing the order amount if the other stays fixed. In other words, there have to be some trade-off. So if one decides to increase, the other one must decrease their order. So if that does not happen, then it's not an efficient or effective decision. So there is a sort of efficiency frontier. All right. I'm just going to skip through this. This is what Nash equilibrium looks like, where based on one decision, say for example, if one decides to order 18,000, then it looks like the other should be ordering just under 14,400. However, if you want to optimize that decision, the best response is along this red line right here. So the second dealer should really be ordering not this amount, which coincides with the 18,000, but rather this amount, somewhere under 10,000 units. So this graph sort of gives us an indication as to how the two dealers ought to be responding to each other. But because they may or may not have enough information, chances are that the decisions that are actually made are not going to be optimum. Okay? What happens when the amount of search increases? In other words, if 10% of customers will search other dealers, or 20% or 30%, what happens to that? So if there's a fair amount of search, each retailer's order quantity and profit tends to increase because most of the customers are going to keep searching. So it makes sense to actually keep more inventory, not less. The retailer's total expected profit will be higher in the centralized pooling system than in the decentralized system. So that's the other thing too. At what point, when we examine the search level, does the centralized system actually do better? So because search does not really matter in a centralized system, what happens is that there's an optimal performance that you get out of that centralized system. That becomes a benchmark for decentralized systems, and you want to make sure that if the expected profit depending on the search level, it does not quite match up to that benchmark, then you go for centralized system. But if it actually exceeds that, then you go for decentralized system. So there's some relationship between the two things, search level and whether or not it's better to go with a centralized versus decentralized system. So with a larger alpha value, which is the search level, retailers will order more in a decentralized system. The manufacturer will prefer a decentralized system because the manufacturer gets to sell more product. However, smaller alpha, the manufacturer will order, actually that should not be manufacturer, actually the retailers will tend to, or the dealers will tend to order less. And so the manufacturer does not get to sell as much. And so the manufacturer would actually prefer a centralized pooling system in a case like that. Both the retailers and the manufacturers would prefer that. Okay, so this kind of shows you, so this is kind of what you expect to get out of a centralized system right here in terms of performance. So anything below this says go centralized, but anything above that suggests that you want to go with a decentralized system. All right. So just to kind of reiterate the concept here, the presence of a search level. If customers are going to search, then manufacturers tend to prefer the centralized system below that level. Otherwise, manufacturer prefers the decentralized system. That's from the graph that I just sort of showed you here. So the question is, if you could make more money under a system that has a fairly high search level, how can you encourage search? And so to encourage search, obviously what you want to focus on is improving brand loyalty. That's why customers search, because they want a brand. And, if you have if you're big on the Ford product, on Ford Explorer, then you will search until you find one. Or a Lexus, you'll search until you find one. So you increase brand loyalty. Information technology initiatives to increase communication between the retailers, increase the ease of which customers can search. So online websites and so on that allows you to know what inventories are available at different places. And if it's relatively easy for people to get information on what's available at other retailers, then there's a greater likelihood that they will actually search. So nowadays with online purchasing, people search all the time. Let's discuss quickly the concept of transshipment, which is shipment of items between different facilities at the same level in the supply chain. So shipment between manufacturers, as a form of transshipment, or shipment between distribution centers or warehouses, that is, or shipment between retailers. And in a lot of cases it tends to occur mostly at the retailer level. It can be achieved if you have advanced information systems, shipping costs are reasonable, retailers have the same owner. So in a case like Best Buy, for example, if you go to Best Buy in Clayton Park or Bears Lake, they don't have the product, they will contact Best Buy at Dartmouth Crossing and could have the product actually shipped across to Best Buy. But because the distance is relatively short, they might simply say, okay, you could actually go there and pick it up yourself. But in some cases, what if there was a Best Buy in Sydney? Then they would ask Sydney to actually ship the product up to Halifax, and then that would be a form of transshipment. All right. However, if you have the two retailers are owned by different people, one would not want to aid another competitor. So there are different strategies that would be required in a case like that. So it's not clear how to actually get that system optimized, but some form of integration to create a virtual transshipment system is what you will actually be looking for. All right. Which strategy to adopt? Different approaches to different products. Definitely, because products have different distribution patterns, not distribution, but demand patterns, service level requirements, cost, and so forth. So some of the factors you look at: customer demand and location, the service level, cost, transportation costs, and demand variability. And all those things actually impact the distribution strategies. So we could see here risk pooling, transportation costs, holding costs, and allocation. These are attributes. And risk pooling, when you have inventory at warehouses, that actually can be taken advantage of from centralization. Transportation costs and cross-docking, you want to focus on what you get the benefit of is a reduced inbound costs. And at warehouses themselves, if you have multiple distribution centers, you also want to focus on reduced inbound costs. In terms of direct shipment, there's typically no holding costs, cross-docking, no holding costs, but you do have holding costs at centralized or decentralized systems. Okay. In terms of product allocation, cross-docking is delayed, at warehouses delayed. Direct shipment, you don't have an issue because it goes directly to the customers. It's delayed here, and so that impacts lead time. What that simply means is that you have to wait to receive an order, the supply must become available, and then it's shipped. So there's some sort of delay in that system. So distribution strategies have cost implications. They have an impact on your service level and on your profit levels. So picking the right distribution strategy is crucial for optimizing profit in the supply chain.